This lesson we're going to talk about area of parallelogram. In our last couple of lessons, we've addressed area of circles, squares, triangles, and rectangles. Today specifically, we're going to look at other parallelograms and rhombuses. The area and we'll touch on perimeter, although perimeter is not a concept that will be on your worksheet for practice because perimeter is something you've been doing for a long time. So let's look at a rhombus. So remember, a rhombus is just simply a diamond shape. That someone has turned over on its side. So it's just a diamond, just like that. And the rhombus also has a height, excuse me, just like a triangle has a height. So we're going to drop an altitude from this corner straight down. And that's going to be the height. You can also have this height measured on the outside of the rhombus, right there. And in some of your diagrams, you will have that picture. What you need to remember is these are both right angles because the altitude comes straight down from the top. So that's a right angle on both of those. Either one that you get that has the height for you, it's a right angle. So we'll call this the height and the height. So in a rhombus, all four sides are equal, just like a square. That's one of the characteristics that a rhombus shares with a square. The difference between it and a square are these angles are not 90 degrees. So this angle, it's not 90, but because it's a parallelogram, it's equal to that angle. And this angle, it's not 90 like a square, but because it's a parallelogram, it's equal to that angle. And remember, opposite sides are parallel. So this side is parallel to the base, and this side is parallel to this side. Hence the definition parallelogram, because a rhombus is nothing more than a parallelogram. All right, so the area of a parallelogram is just the base times the height. Any parallelogram. So the base times the height. Well, in this one, the base is the length of that side, so you could just say SH. For the perimeter, it's all four sides. So for a parallelogram that's a rhombus, it would be just like a square. So it's S plus S plus S plus S, which is 4S. So to get the perimeter, you just go all the way around the outside of the shape and add up the lengths of all of the sides. No different. So any parallelogram you can find the area equals the base times the height. Not trapezoid though. These are not specific characteristics of the ones that we have addressed. Square, rectangle, circle, triangle. These are your other parallelograms, such as a rhombus. So your miscellaneous parallelogram, base times height. Remember, the trapezoid was the sum of the bases, 1/2 the sum of the bases was your area on a trapezoid. Times the height. So trapezoid, this is not what we're talking about. Do not clue this in with trapezoid. Trapezoid is 1/2 the sum of the bases times the height. we're just talking about rhombuses or parallelograms that look like a rhombus but might not be a rhombus. Now there's another formula for the area of just a rhombus only. You can find the area by taking 1/2 the product of the diagonal. So diagonal 1 times diagonal 2 times 1/2. So remember the diagonal were those things that went across the middle of this shape. So diagonal 1 and diagonal 2 would be this one. There's diagonal 2. And diagonal 1 is this one. So what you can do is take 1/2 the product of the length of those diameters in a rhombus. So it's 1/2 the product of the length of the diameter. That's only for a rhombus. But other parallelograms, not trapezoids, are usually always base times height. And the perimeter doesn't change either. So let's put some of this into action on our worksheet. Let's look at some of the examples that you're going to be doing. Okay. Let me hold on one second. I'm going to move this to a different screen. There we go. Now, if we look at number 1, it's a parallelogram, and our area is base times height. So it's simply 5 times 4, which is 20. Correct answer, C. Easy peasy. Number 2, the same, base times height. Okay, on number 4, that is not a plain old parallelogram. That is a trapezoid. So on number 4, we have something different. For a trapezoid, your area is 1/2 B1 plus B2 times the height. So write that formula down for the area of a trapezoid. Little different than a rhombus or a plain old parallelogram. The trapezoid is its own animal. So on this one, number 4, 1/2 the sum of the bases times the height on this trapezoid. Well, the base is, one of the bases is, let's just plug them in. So the area equals 1/2 5.9 plus 2.5 times the height. We'll pop that into our calculator. So we're going to look at our calculator. And we're going to put in there 1/2 the sum of our bases times the height. So we're going to put that in exactly like we wrote it. So we've got N over D. We'll put our 1/2 in. So 1, directional pad down, 2, directional pad to the right, and now we'll put our parentheses. So we got our sum in there, 5.9 plus 2.5. All of that times the height at the end, so times 2. And there you go. There's the area of that trapezoid. We'll check and make sure all of our units are the same. They are. Everything is in yards. So we've got 8.4 is our final answer for the area of that trapezoid. So the trapezoid is a new one. It's a new formula for area. Now, what if you wanted to find the perimeter of a trapezoid? That's a little different. Finding the area is no more than putting it into the formula, but the perimeter is a tad bit different. So we're going to do a trapezoid. Take the rhombus off there. And let's draw us a trapezoid. All right, there's our trapezoid. So remember, there is a height on a trapezoid, just like a rhombus or a parallelogram or that triangle. It's an altitude, drops straight down, perpendicular to the base. There's our height, just like so. Now what we need to do is get some measurements in here because we need to figure out how to do the perimeter of this trapezoid. What if we had .3 on the top and 7.9 trying to get my measurements in there. 2.3 centimeters on the top of this, and the base is 7.9 centimeters, and our height is 30 millimeters. Now remember, this base is all the way across. So if we're going to find the perimeter, we're going to need to add up all four sides. We're going to have to utilize Pythagorean theorem and what we've learned so far with the hypotenuse and side length to figure out those missing two sides. Now that second altitude that I just drew in, it's exactly the same height as the other one because it's also perpendicular. So it's 30 millimeters. If you notice, we've got units in both millimeters and centimeters. So let's convert all those millimeters to centimeters. Let's go one more time back to our unit conversion. So 1 meter equals 100 centimeters. I know that. And I know 1 meter equals 1,000 millimeters because that's what the suffix centa and milli mean. Cent, 100 pennies in a dollar. That's why we call it a cent because the prefix cent means 100. So there's a factor of 10. Do you see between centimeter and millimeter, we only add 1 0? So 1 centimeter is 10 millimeters. So if we're going to convert our measurements to centimeter, we're going to go from millimeter to centimeter. So we're going to go this way. That's getting smaller. That means we're going to have to divide because it's getting littler. So we're going to divide by 10. So that means that this is 3 centimeters tall. Bless you. 3 centimeters, and 3 centimeters. Okay, so I know this triangle over here on the left, we're going to start with it first because I need to figure out the length of the hypotenuse. I also am going to have to find the length of the hypotenuse on this side as well. But to find those, I need the measurements of the leg. So I actually need this leg, and I need the other leg, this leg. Is there some way that I can figure some of this out? Well, I know in this larger shape, the total distance here in the middle is 2.3 centimeters. And what if I was given 1.2 centimeters for the base of that yellow triangle? I was given a 1.2 right there. How would I figure out the base of the blue triangle? Well, that's 7.9 minus 1.2 minus 2.3. So when we do that subtraction, we'll be left with that base of that blue triangle that we've created using the height or the altitude of this trapezoid. So we'll do that on our calculator. 7.9 minus 1.2 minus 2.3. Seven point nine minus 1.2 minus 2.3. 4.4. So the base of that blue triangle is a 4.4 centimeters. Now, why did I need to know that piece of information? If I'm going to find the perimeter of this trapezoid, I have got to know this distance, and I have got to know this distance. Well, those are hypotenuses to those right triangles inside. I have to use Pythagorean theorem to figure out the length of that hypotenuse, because remember, this 3 centimeters is the height, not the length of the hypotenuse. So now let's use Pythagorean theorem to figure out the height or the hypotenuse of the orange triangle on the right. So we have c squared equals a squared, 1.2, plus b squared, that's 3. That's my short leg and my long leg. So c squared equals 1.2 squared. What is that? So we'll go over to our calculator. 1.2 up arrow squared, directional pad to the right, enter. That's 1.44. 3 squared is 9. So c squared equals 10.44. Do you remember from these lessons how we eliminate that square because we need C, and that's just taking the square root. So whatever the square root of 10.44 is, that is what our length of our hypotenuse is. So we can do that on our calculator. The square root of 10.44. So to do that, we're going to go second, find that x squared button, put your 10.44 in. That's 3.23. So the length of that hypotenuse of that orange triangle is, I already forgot it, 3.23 centimeters. Same process for the blue triangle. So we have c squared equals a squared plus b squared, just Pythagorean theorem. So c squared, we are looking for, one of the legs is 4.4. That's that bottom piece. And the height is still 3 squared. That's our other leg. It's the same height as the other triangle. So c squared equals 4.4 squared plus 9. So let's figure out what 4.4 squared is on our calculator. 4.4 up arrow squared, enter. That's 19.36, and I already know I'm going to add 9 to it. 19.36 and 28.36. 19.36 so c squared equals 28.36. How do we get c out from under that exponent? We're going to take the square root of both sides. So whatever the square root of 28.36 is, that's what our c, or our hypotenuse of this blue triangle, is. So we need the square root of 28.36. Sometimes there are shortcuts, but we're not going to take those. Second, we're actually going to type this in. I don't want you to learn to use those shortcuts. So the square root of 28.36 is 5.33. And that's an estimate, of course. It's not going to be exact on this one because our square roots didn't come out exact, and we don't have exact measurements for things. We had to estimate. So now if we're looking for perimeter, that's the whole reason we started this. The perimeter of this trapezoid is going to be 3.23 plus 7.9 plus 5.33 plus 2.3. So you're just going to add up the 4 measurements of the 4 sides. The problem is we had to use Pythagorean theorem. There's your 3.23, 7.9, 5.33, 2.3. That's all the way around the outside. That is your perimeter. We just had to take 2 extra steps to figure out those 2 missing side lengths. So for trapezoids will give you a little difficulty on your perimeter because you're going to have to bring in everything you've learned about triangles to find missing lengths sometimes. Okay. And I think that concludes our lesson on perimeter and area of trapezoids and rhombuses. You are ready to do this worksheet now. Remember, You're going to have to upload a picture of your note, handwritten. You're going to have to upload all your work shown, draw the pictures, label them, show the algebra that you did, show all your steps. You're going to use homework help. For any struggle, they will make sure you get all the answers correct, and then you're going to put your multiple choice answers into the Google form. I will see you in the next lesson. Have a great day.